Welcome back. Today we're going to be simplifying some trig expressions and verifying some trig identities. To verify an identity means to prove that it's true. Alright, and these examples today, some of them are going to be a lot of work. I think though that they're going to introduce you to some skills that will be helpful for solving more complicated problems or for simplifying or proving more complicated problems, such as the ones you may see in today's lesson. So, to begin, first off, let's sine and cosine this one out. We need to simplify it, so we want to make it into a single trig function, no fractions. 1 over sine of x. This becomes, using our reciprocal identity, cosine of x over sine of x, plus sine of x over cosine of x. This denominator here I see as two fractions. If we use common denominators, we can combine them into a single fraction. So our numerator remains unchanged. Now my common denominator will be the two denominators multiplied together. So that would be sine x, cosine x. This first fraction then needs to get multiplied by cosine of x over cosine of x in order to get that denominator. When I do that, cosine of x times cosine of x, cosine squared of x, and then cosine of x times the sine of x on the bottom. Got sine times cosine. Plus, in order to get this denominator into that, we need to multiply the bottom and top by sine of x. The bottom becomes what we want it to be, and then the top is sine of x times that top, which is sine squared of x. Now, I'm going to continue down in this row. Top remains the same. Add these two fractions together. Use our common denominator. And then we've got cosine squared of x plus sine squared of x. Now, cosine squared of x plus sine squared of x, that's one of our Pythagorean identities. That equals 1 over sine cosine. Now I've got fraction divided by a fraction. I'm going to keep the first fraction, change division to multiplication, and then flip the second fraction. Sine of x, cosine of x, all over 1. And multiply these two fractions together. Common factors on top and bottom cancel each other out. And that equals cosine of x on top, 1 on the bottom. Cosine of x divided by 1 is cosine of x. So that one is simplified. Next up, sine and cosine it out. Tangent of x is sine over cosine. Cosecant is 1 over sine. Got two fractions being multiplied together. We can cancel out the common factor. And we have sine of x over 1 on top. And I'm going to keep this fraction right here. Change divide into multiply. And then flip the second fraction into sine of x over 1. Sine times sine is sine squared of x over 1 times 1, which is 1. Divide something by 1, that stays the same. We've got sine squared of x. Now, verify these. Remember, verify. So the word verify, I believe, comes from an old French word, which I don't know how to pronounce. It has Latin roots. for the VER, it's related to words like veritas, which means truth, vere, which I believe means truly or true, and then the FY part comes from, is related to the word verificare, the facere, which means to make. So we want to make this to be true. Now, we already know it's true. We essentially want to prove that it's true. Anyway, that's some etymology there. Not really the math, but you might remember what verify means on account of the explanation. So anyway, let's get to work. This left side looks more complicated to me, so we will work with that. I'm going to reorder this so we have terms in descending order. Now this is a trinomial. One of the ways that we can factor a trinomial is to try to make it into the product of two binomials. So something plus or minus something, something plus or minus something. So we got 4 spots to fill in. The things in the first 2 spots need to multiply together to get sine to the 4th power. One of the ways we can do that is by doing sine squared in both spots. Multiply to get sine to the 4th. Next up, these last 2 spots need to multiply together to get positive 1. So I know it's going to be 1 times 1. I also know it's going to be a minus 1 in both spots because I have to introduce a negative into the expression somehow. Now if you used FOIL to multiply this out to check your work, you'll see that it does in fact equal what we were trying to factor. And so this is a valid way to factor this. Now, I look inside each of these set of parentheses. And I look, and I don't have a identity that I can sub in place of this. So what can we do with it? Now, here's what we can do with it. I mentioned back in an earlier lesson that if you've got a trig function squared and a 1, but the pluses and minuses don't quite match up to an identity, what you can do is you can factor out a negative 1. So we're going to factor out a negative 1 from both of those. And then this would be, remember this is multiplying in between here, times, I'll factor out a negative 1, a negative sine squared of r, plus 1. Next thing that I'd like to point out is that we have multiplication going on all the way across. Negative 1 times this, times negative 1 times that. Now remember the commutative property of multiplication, which says that when you're multiplying, you can rearrange the order of your multiplication. So that's what I'm going to do. I'm going to rearrange this order so that the 2 negative 1s are multiplied together first. If we do that, this negative 1 times negative 1 is positive 1. And so this would just be positive 1 times each of our sets of parentheses. Since it's 1 times something else, you can really just ignore the 1 times. Next, I'm going to rearrange the order since we're adding, and we could use the commutative property of adding. Now, 1 minus sine squared of an angle is one of our Pythagorean identities, and that equals cosine of the angle. Cosine squared of the angle. Alright, so check this out now. 1 times cosine squared of an angle is just cosine squared of the angle. So we can really just ignore that times 1. Now, cosine squared times cosine squared is cosine to the 4th. Because when we have the same base, the rule is, when we have the same base and we're multiplying, add the exponents. So 2 plus 2 is 4. We've got cosine of r to the 4th power. Or cosine to the 4th power of r. Now that's exactly what we wanted to show. And so we've just shown that that first identity is in fact true. Next up, all right, for this one here, let's sine and cosine it out. Sine of u, cosine of u, and then we'll just rewrite the rest. Now I've got two fractions, and so one of my strategies is to get common denominators. So I'm going to do that. My common denominator is going to be cosine of u times 1 plus the sine of u. That's what I'm going to want my bottom of the fraction to look like. To make this fraction have the bottom look like that, I need to multiply it by 1 plus the sine of u on the top and bottom. To make this fraction have that denominator, you need to multiply by cosine of u, or cosine of u. All right. And of course, when we multiply this cosine of u times that denominator, we would need to multiply by both things, and we signify that by putting parentheses around it. All right, now we have two fractions with the same denominator. So I'm going to add those two fractions together. All right, now I'm going to leave this and not use the distributive property on it. And you might see the reason why in a moment. For this, then, I am going to use the distributive property. And then you might be asking, like, Mr. Pohl, how do you know when to use the distributive property and when not to? Well, here's how I know that we would need to use the distributive property here. Because I foresee that if we did the distributive property up top, I'm going to end up with a sine squared plus a, whoops, this wouldn't be a 1, this would be a sine of u, because we use the distributive property from here to there. I see that after using the distributive property, we're going to have a sine squared plus cosine squared. And I remember from my trig identities that that equals 1. And that will allow us, by doing the distributive property here, to simplify the expression. And it's going to be very handy the way it does simplify. Because sine squared plus cosine squared is 1, and then the bottom looks like this. Now here's the reason why I didn't use the distributive property on the bottom. Because I saw that this sine of u plus 1 is the same thing as 1 plus the sine of u. So once we've got it factored, we can cancel them out, and we'll have 1 over the cosine of u. Reciprocal identity says that that equals the secant of u, which is exactly what we wanted to show. And therefore, we have demonstrated that identity. All right, last two. Since this video is almost up to 15 minutes, I'm going to stop it and pick things up in video number 2.